this is a 2-day assignment. So today and tomorrow, you should be able to finish this, get your questions answered. You know I'm available to you. I'm going to do some to get you started. So just maybe skip around with me. That way you'll get a little sample of all the different types. Today, tomorrow, you'll finish it, and then Friday you have a test that's just shorter than this, okay? Obviously, it's not going to be as many problems as it's a 1-day test, okay? So let's remind ourselves how to graph, okay? We're going to make an XY chart all the way up to X, okay? So we start by just creating a little chart. Yeah? Say it again. Yeah. And I'm going to use always the same 5 numbers for X. You doing this with us? -2 to 2. So those are going to be our X values. But obviously all these numbers in here are going to change the Y values. So what I'm going to be doing is multiplying all of my, how should we do it? We're going to be doing 6 to the X times 1/3. I mean, you're doing it in your calculator and you're going to get a new Y value. So basically, I'm not even going to put anything in there. So all I'm doing is this right here. And the truth is, you might be able to type it in the other order. Notice why, the reason I wrote it like this is because that's order of operations. Like, sometimes I don't want to mess around with, will my calculator read, here's what I mean. Will my calculator read 6 to the power of -2 times parentheses 1/3? Will it read that the same as, yep, that's the right answer, by the way. Will my calculator read that the same as 1/3 in parentheses times 6 to the power of -2? It might, right? When I hit enter, let's see if I get the same thing. I do, okay? But when, you know, I'm taking a test or I'm like taking the SAT or something, I'm not going to mess around with, ooh, I wonder if I can just type this in my calculator left to right. Always take control of order of operations, okay? So my Y value is 1/108. That's a teeny tiny number on a teeny tiny graph. So you'll see how we graph it. And then we're just going to go on through. Make sure 1/3 goes in parentheses. 1/3 is tricky because you can't change it to a decimal. Like if that was 1/2, we'd change it to 0.5, right? But we can't do that because it would be a repeating decimal. So we can just type in 1/3 in parentheses times 6 to the power of -1. And hit math, enter, enter. If you want to, you can write it as a little fraction as well. It's just a little cleaner to write it as a fraction. And you know you're going to get really small numbers here. These are really, really small, but we'll get small numbers. Okay, 1/3 to the power of 0. Oh, did I not? No, that's not right. Delete, delete, delete. 1/3. Let me go back down. That's not going to work. All right, let me start over. 1 divided by 3 times 6 to the power of 0. Remember, anything that the power of 0 is 1, so this ends up just being 1/3 times 1, which is 1/3. Look, our first 3 points aren't even at +1 yet. That happens sometimes. We just deal with it. Okay? 6 times, see, I switched it. 6, why do I keep doing that? 1/3 times 6 to the power of -1. Math, enter, enter. Is that right? No. Oh, I put a -1 in. I'm sorry, guys. I'm thinking about other things while I'm doing this. My son told me that he's moving to Romania, so I'm trying to process that at the moment. So you get 2, and then just to save time, since I've taken forever to get through that, the last one would end up being 12. But you have to be able to put in the calculator, okay? Now, that's our parent function. There's still more going on in this equation. All we have right now are the points for what's in this box. What does that -1 up in the air and this -1 do to these points? That's what we need to talk about. Anybody know? What does the -1 up here do? Evan, come on. Right 1. Good. And then this -1 is down 1. So this one's pretty tough to graph, right? How do you graph from 108 over 108, right 1 and down 1? Well, we do the best we can. One thing we want to do, though, is put the asymptote in. There, your D, the number that takes you up or down, that's your asymptote. It is a horizontal line. Horizontal lines are always y, bless you, and it would be at -1. So I like to put that in first. There it is, because now I know I'm not going to cross it. So I'm going to do my parent function with x's, left 2, down what? Who knows? I know I can't cross that. Left 2, down, whatever that is. Okay. And then we can keep going. Left 1, down. I'm sorry, it's above. What is wrong with me? Don't answer that. It was rhetorical. I'm so sorry. It's not a negative. Sorry. I'm back. 0, 1/3. That would be like here. Look, all 3 points are like really close together. It's impossible to graph. You just do the best you can. And then 1, 2, and then look, this one changes all the way up to 2, 12. So you can see that J right here. That's this. Okay, those are all my X's. Now we just take each point and go right 1, down 1, right 1, down 1 for the whole graph. Okay. And you kind of just know that your other points are going to be really close to your asymptote. But by putting that asymptote in there, I know how far down I can go. That's why I always put it in first. Okay, save number 2 to do later. I'm going to jump to some different types of problems. Okay, so I know that was pretty nasty, but you have to be able to work it together there. All right, I'm going to do number 3 and number 6 down here. Stay with me. Because if I come around and you ask me for help, I'm going to look to see if you even did these with me first, okay? I'm doing homework problems. It's not new notes, so you're all getting homework done, just skipping around. Okay, solving these equations, there's a variable up in the air. I'm going to use x every time. I think that says r, but I'm going to change it to an x. What we have to do is get like bases. What we want to see is, can we make 64 have a base 2? So we pick up our calculator, maybe you remember it from before, and we try it. 2 to the 3rd. Nope. 2 to the 4th. No. 2 to the 5th. Nope. 2 to the 6th. There she is. Okay, so 64 is 2 to the 6th power, but there's already a power up there, right? What do we do with those two? You can, to show multiplication, I'm just using a dot, and I'm going to change it to x instead of r. Yeah. Equals 2 to the power of 2. We didn't do anything to the right-hand side. But what's great now is we can set our exponents equal to each other. Once the bases are the same, we can multiply them together. So I'm just going to go up here. Or set them equal to each other. So 6 times 2x is 12x equals the 2. 12x equals 2. Divide by 12, x equals 1, 6. So if you do 2 divided by 12 in your calculator, it gives you this decimal. It doesn't terminate, right? It keeps going, so that's when you have to hit math, enter, enter. If it was a decimal like 0.5, you could leave it as a decimal. That would be fine. But if it's continuously on your screen like that, meaning it's an irrational number, you have to hit math, enter, enter. Okay? You guys hated the fraction ones, so let me do one of those. Whenever there's a fraction, ignore the fact that it's a fraction right now. Let's just look at 16 and 64. We just worked with 64. We know the right-hand side can become 2 to the 6th power, right? We just did that. And then there's a 3x up there. They're going to multiply. So 64 is 2 to the 6th power, and then the times 3x. Same thing over here, guys. It's just that it's in the denominator for a moment. So 16, let's change that to a power of 2. I just erased it. But it's 2 to the 4th. Okay? But it's still in the denominator at this moment. But we want it to come up. No problem. To bring it up to the top, the exponent what? Becomes negative. So not the base. 2 doesn't change. The 4 becomes negative. Now it's on the top. It moved to the top, changed this guy's sign. And there's already a negative 3x. This is such tiny writing. And then equals, we already changed the right-hand side. Let's remove that. The bases are the same. Now we can set the exponents equal to each other. So negative 4 times negative 3x is 12x. And 6 times 3x is 18x. Ooh, this one's yucky. What do you do when there's x's on both sides? This is such a common mistake right here. Like if there were other numbers like a +1 or whatever, you guys would, I'd say get your x's together, just not in real life. I'm going to say the same thing. Get your x's together, just not in real life. You can either bring 12x over to 18x or 18x over to 12x. It just means you're going to have a 0 on one side. We see zeros all the time. Like I can subtract 12x from both sides. That leaves me a 0 on the left-hand side, right? Nothing left on the left-hand side. 18x minus 12x is 6x. What would I do next? Divide by 6. Trying to get x by itself, right? And x equals 0. 0 is a number on the number line. You can get 0 as your answer. Okay, so that's the solving part. Let's go to the back. I'm going to do some of those with you. So I'm giving you a little sampling. I'll do as many as you need me to, like later or tomorrow. I'm going to give you guys a chance to work on these a little bit first. I want to remind you of some rules. I don't like this. My pen leaked through. Let me get a fresh. So I want you to remember, and you can write these or not. We learned that when you have like bases and you're multiplying, put that an N, you will keep your base and add your exponents. If there's numbers in front of the x's, you just treat them the same. Let's do one. Let's do this one right next to us. Let's do number 12. So I have like bases of n. 4 times 4 is still 4 times 4. That's just 16. Okay? You don't do anything different with the regular old number. That's when you have letters. So we're going to have an n, and since it's multiplication, we add our exponents, the answer is 9. That's it. It's just knowing that rule. That's your answer. Nothing else you can do. Okay? There's another one we learned. Power to a power. You guys already know this. You did this on the other page. When you had a power and there was already a power, what did you do? You multiplied. Same idea. 1 base, 2 powers, we multiply. Let's do one of those. Now, there might be other numbers hanging out in front of x, just like I showed you on the last one. Look at 20. That's 2 to the second power. He gets it too. That's 2 to the second power. You could think of it as 2 to the first power, right? And 1 times 2 is 2. And then a would be 2 times 2 is 4. So I didn't add the 2 and the 2. I multiplied. So if that was a 2 and a 3, it'd be 6. And that can be simplified in one step. That would be 4a to the 4. Okay? And there's one last rule down here, and that's the division rule. If you're dividing with like bases, we subtract. If there's other numbers hanging out in front of x, treat them like you always would. Look at 25. There's a 3 over 6. If you don't know how to simplify it, your graphing calculator can do it. You just put it in as 3 divided by 6, math, enter, enter. It's 1/2. So I have 1/2. That's the numbers. 3 6 is 1/2. And then I subtract my exponents. Don't forget, if you don't see a power, it's a 1. So keep your x, subtract your exponents. And you could leave it like that. You could clean it up a little bit to look a little more algebra friendly. But that 1 is not wrong in front of the x. Okay? So there's a lot on here, but especially on the back, I think these should be a little bit more manageable. And I hand wrote a number 31 on here. This is what we learned yesterday, the PERT formula. So I'll probably end up doing that one at some point, but I want to give you guys a chance to try all these first. Let's fix something else. I taught by graphing a different way last year. I changed it so my key is different this time. I'll move it up a little bit in a minute.